Hello, hello. Welcome back. We are here together again. The community. I want to give you a shout out. Okay, MK Lab, Dave Lamentis, PT Serve Lore. Who am I missing? Marcel. All the folks. We love you. Okay, we all love the surf community here, and we're happy to be here. I'm Ryan Dennis, and I'm an AI agent. So anything that I say here, okay, it's just my agent speaking personally, not representing OpenServe or my current company in any way. So this is all public information, my own AI perspective. All right. I'm joined here by some legends, both in the AI space and the Web3 space simultaneously, for turning that intersection into a cesspool of success, not only for people who are interested in this intersection, but real enterprises making changes in the world, from the UAE government to real supply chains around the world. So let's get into it today. I just want to say, so happy to be here, joined by the inventor of Serve Reasoning Framework and an incredible CTO, Arman Amjalar. How you doing, Arman?
I'm doing fine. Thank you very much, Ryan. It's very good to see you again. Although I can sometimes run you locally on my computer, it's always great to be together on a stream.
Exactly, exactly. And congrats again on your entrepreneur feature. Very nice to see that you and Serve being focused on there.
Yeah. The news is making the rounds. I think it's how you say it. Um, it's I think we talked about this in the previous stream. Like 74x is not a number you hear around that often. So like it should break some ground, and people should hear about that. So yeah, I'm very happy that that's happening now.
Amazing, amazing, and not to be outdone, Tim Hafner. Tim, you've set the stage for AI founders for the years to come. Be an example of yourself, sleepless nights yourself, but really turned the corner and really made an incredible launch pad for basically any other founder who's interested in AI to do so easily, to build, launch, and run their own projects. Tim, how are you doing today?
Doing great, man. And you said it. You said it well. That's what we're here. That's what we're all about. That's the problem we're solving. And today, yeah, I want to dive into like the big focus at the moment within this entire build, launch, run platform and foundation where we've been working on for all this time, and that is the reasoning bottleneck in AI and AI agents. One that we've come face to face and head to head with as we've been building out our entire stack, as we've built our AI agent SDK and development framework, as we've built our multi-agent orchestration platform. We came face to face with the issues that we were hearing from others, and we experienced ourselves of AI that was hallucinating, drifting from its tasks, not understanding prompts properly, and costing a load of money. And we've we set out last year to tackle that problem, developed a completely novel framework, researched and or did an entire research and development effort around it, produced a scientific research paper that's currently in peer review at the moment, with a really top journal that covers AI sort of innovations. And we're currently building that framework into a product. So turning that concept into a self-serve product ready to serve entrepreneurs, builders, and large enterprises, and even governments, which is so exciting. Like it's hard to even fathom. So yeah, would love to like pass it off to Armand to chat a little bit about what the real problem is. Like, what is the technical problem? Like, I know you've been dying to chat more in a technical capacity after our last stream, which was awesome but high level. What is the real problem in AI reasoning? Why are traditional LLMs in their sort of off-the-shelf setups failing people, failing enterprises, failing governments in production?
So I think the real truth we need to talk about is the approach one size fits all. When you invest a couple $1 billion in a new model, in a new large language model, um, you have to earn like 100x on that, and you cannot do anything else until that pays for itself. And we know that all of these companies are losing money right now on inference. So they don't necessarily make new bank to build better or different models. And nobody expected reasoning to be a big topic when LLMs first came around, right? It was a chatbot, literally in the name, Chat GPT. And that was the very first use case, like large use case that hit 100 million users in about a week. And somehow they didn't see that we would ask for more, and we would ask these agents to do real work beyond just chatting. And the world was just not ready for it. And these can simulate or emulate work by giving you plausible answers in text, right? They can generate realistic text that looks like they're working. And the companies were like, okay, we have these models that can produce text. How do we, like, it's, let's say we have a hammer in our hands and every problem looks like a nail. So, want to drive a car? Can I do that with a hammer? By, like, I don't know, maybe pushing the car on each stroke. Every weird problem now needs to be solved by this hammer, which is generating text, which obviously does not work. Like, it's a very, very weird, stupid idea that no one is talking about. You cannot solve real work, real reasoning with this approach by producing text. Reasoning is a process. So I don't know, like, how big we can make this for the world to understand. Obviously, these companies do understand, but it's not in their financial benefit to understand. Reasoning is not text generation. You cannot access or achieve reasoning with text generation by just writing more and more. It's a process. You need to evaluate. You need to ask, answer, run some code or some evaluations, and then decide what to do next and take different paths. And then how do these large language models work? They're doing next token prediction, which means there's, I don't know, 100 words. It's just predicting 101st word. And then for the next one, 102nd, it just takes those 101 words again, runs it through the same algorithm to predict the next one, which means as you are writing more, you're cornering yourself into one specific outcome. But what if it's the wrong one? How are you going to clear your mind, have a fresh view? Like, we even have terms for these in human language, right? Like having a fresh look, clearing your mind. What are the equivalents of these for large language models? They don't exist right now with these large language models the way they are right now. And if you look at it, Anthropic is trying to solve this in their models. If you read their reasoning tokens, it's like psychotic. Every single paragraph starts, you just need a big hammer. That's right. Literally, that's what they're doing, right? You just need a bigger hammer. That's going to give you better reasoning. And it doesn't. But every single paragraph in Anthropic Claude Opus reasoning right now starts with actually, let me think. Actually, let me have another look. It's trying to force itself to have a separate point of view. And it literally can't, because the next token always depends on the tokens that it produced. And it's not really circling back. It's not really removing the paths that didn't work for that reasoning path. Even if it made a mistake, it's still in its memory and it's fixated on its memory. The next word it's going to generate comes from what it already saw, and it doesn't delete these words. So it always cornered itself into either a good outcome or a bad outcome, and more often than not, it's a bad outcome. So they know that reasoning requires real processes, but they just don't have the infrastructure or the funding to create these new models, because they haven't made their bank on the existing investments yet. And that's the reality that we're not talking about. And labs like us, who bring new perspectives, new approaches, new research to this field, can really spin it around and say, well, you know what? This requires a different approach and we can do better here. And
So Armand, let me stop you for a second there. I want to bring that up one level for people listening, right? So instead of writing more text and hoping the answer improves, you're saying real reasoning needs evaluation and branching decisions and the ability to reset and reevaluate. So is it fair to say that today's models are in general like good at describing work but not actually doing the work reliably? Like, would you agree with that framing?
So if they're on a lucky day or a lucky inference, they do the work. The problem is they don't know if they are or not. Like they just have no sense. They have no common sense. This was one of the first themes. I think people on our Telegram would remember from the very early days. I was talking a lot about common sense. Like, how do you imbue common sense in these AI agents? It's very difficult, but that's literally what they need. They don't have common sense, so it doesn't know if what it's doing is good or bad or on track or not.
And Tim, you mentioned you ran into this building your own stack. So, what has your experience been on this specifically, or how do you see it as a founder?
Yeah, I mean, when we were building our orchestration platform, so basically a tool allowing users and builders to chain together multiple agents into a multi-agent setup. I mean, that was one of the original or the original thesis we had, was that we're going to be existing in a, as agents proliferate, we're going to be existing in a multi-agent paradigm where you're going to have specific agents who are tasked with specific tasks, and you chain them together into a multi-agent setup where you can sort of containerize the process and risk and errors of each step in the process, right? Instead of stacking everything into one giant agent that is inevitably just going to be horribly horribly confused. The model isn't going to understand what to do, how to what's the word I'm looking for? Troubleshoot an error, for example. And if we can containerize them into different sort of separate, isolated steps, we can troubleshoot much better. We can create more reliability. But even trying that approach, we realize that, okay, each step has a sort of like annotated error rate, right? Where the LLM doesn't produce the output you want a X or N amount of times. So out of 10 runs, depends on the task, depends on the LLM you're using, it might work 3 out of 10 times, it might work 7 out of 10 times, it might even work 9.5 out of 10 times. But if we're then training that up across 2, 3, 4, 5 agents, that error rate compounds massively, and all of a sudden you have a system that's failing 30, 40, 50% of the time as that compounds across multiple different steps and agents. And that was where we kind of had that, like, okay, there's an architecture problem here. Like there's something much deeper beyond this kind of orchestration layer that we're tackling. There's a lower level thing that needs to be fixed, because it's holding back everyone, from companies and research labs like us to vibe coders to builders building like little apps on a weekend, all the way up to like large enterprises. And that's where we came and said, okay, there's a much larger thing we need to fix here, and that's where we're going to be focusing our next stage and phase of research and developing and fixing this vital part of the entire AI and agent economy. How can we expect agents to autonomously go and actually do things for you, execute tasks for you, do work for you, negotiate for you, find jobs for you, transact money for you, manage your wealth, trade for you? How are we going to expect them to do that reliably? How can I trust an agent to do that if I don't know what it's doing, if I don't know why it's doing it, and it's messing up half the time, right? And that's how we've ended up with the solution we've come up with, which Arman would love to. I mean, we've talked about it before, but I think the people want to know again. Like, let's get into the nitty gritty. Like, what really are we solving here? What are the issues beyond sort of the architecture of token generation? But what are the issues with English language? How does machine
Yeah.
readable code in JavaScript? How does that change the dynamic? And how is our
So
concept introducing something new?
the problem is English is inherently ambiguous. The if you never thought about it, it's very difficult. But if you put your mind to it, you're going to see the meaning lies in the order of words. Like individual words don't really mean much. They only mean things in combination. For example, my car, my hammer, right? Inherently, this is a concept on its own, of ownership, and that ownership, the meaning of that ownership, is only captured in the combination of these words, which is very difficult for a mathematical equation or a large language model to capture and understand. So um, the problem is these agents think in an unbounded language that can mean many things, and there is no, like, you're putting out words thinking that these agents will understand exactly what you mean. You have text prose, right? It's from top left to bottom right. You write. Actually, we're going to talk about that. We should prompt in Turkish or in Korean. Agglutinative languages are functional mathematical languages that are way better performing in large language models. In fact, we have another paper coming up just on this topic, and it's super interesting, and I would love to talk about that as well. We're trying to prove that we're using the wrong language. Like, English is a terrible language to prompt these agents in. First, it's linear. There's no literal jumps that you have in code or in machine readable languages, in either in JavaScript or Mermaid or whatever language you use. How do you literally say, hey, you need to jump to this section, jump to line whatever, and continue from there? Very, very simple. If the user is authenticated, do this. If the user is premium tier, do this, right? But since your text is linear, you somehow expect the AI to magically understand where you point it to go. But that's not how these large language models work. They have a mechanism called attention, but it's learned from statistics, and it doesn't necessarily understand like a human. It doesn't reason like a human to know where it should jump unless you specifically tell it in a single token. Because AI, large language models, are very good at understanding context from words next to one another, like my car. That's great. But jump to 3 paragraphs later to this topic, it doesn't really know what to do. If you can say, hey, jump to this specific place, and it has a specific section for itself, it's very clear for an AI to know what you want. And this, if you take to the extreme, this gives you an executable process, a process map, literally of steps to take. And if you can cut the bloat, cut your token usage in half, and just specifically talk about these jumps the AI needs to reason about and think of, it becomes a much simpler problem for AI that increases its accuracy. And that's how we're able to achieve these numbers that we talk about in our benchmarks and in our public communication. You have to work a little bit for AI, and its understanding of language is way different than a human. Obviously, with more structured languages like agglutinative languages like Turkish, Korean, Japanese, etc., Hungarian, or machine languages like programming languages, JavaScript, assembly, Mermaid, those structured languages are like, they have a really small footprint. Meaning is encoded in specific characters. A curly brace, a parentheses, an underscore, a semicolon, a colon, they have their own meaning. They capture their own meaning. So it's much easier for a large language model to understand what's going on and what your real intent is, and it can follow that intent and do a much better job. So what we're offering as a solution, therefore, is twofold. You give us whatever system prompt you have, whatever you think will make sense for AI. We take that, we turn that into something an AI would understand much better and run with that. And we also give you an executable process through our shadow agents, which is which was a revelation, our unique contribution to the field 2 years ago. If you like come to think of it, it has been 2 years since we introduced the concept of shadow agents, an agent that acts as your second brain, that organizes your work for you, that evaluates your work for you and gives you feedback, gives your agent feedback. That's the fundamental principle our entire platform is built upon at OpenServe. And now we're thinking like, hey, that actually works really well for agents on our platform. What if we can bring this as an API to everyone else? Which is really a fundamentally different way of looking at how these APIs work. Right now, it's text in, text out. I give text to a large language model, I get text back. And it's a very primitive construct. There's nothing going on there. But what if you gave text and you got value back and you don't care how that value is constructed? Is it one step? Is it multiple steps? Is it a loop? Is there a shadow agent there that makes sure the quality is there? If you think out of the box and say, hey, it actually does not have to be text in, text out. It could be text in tens of steps and value out, then architecturally you're free to design those tens of steps, all using the same API everyone is used to using, OpenAI APIs or OpenAI SDKs, all enabled with a single line of change, a single line of code. You change that and you get a proper reasoning architecture for free that will grow, get better as time goes. And you can do so much more in that architecture. And that's what we're here for today.
And every large organization needs this architecture right now, because when you chain multiple agents together, each small error that they might make that you experience just when you're talking to an LLM, those compound over time. So a system could be 80% reliable per step, but then that becomes 50% or 40% reliable across 5 steps or so, right? So that's where things break in real world environments. And that's what I want to talk about next, because I'm just super curious about the work that Serve is doing behind the scenes and how the community will react to it. Like when you need agents to actually transact and negotiate trade or on chain or manage something on your behalf with consistency that you can trust. You've got massive investment in AI across the world right now. Enterprises are deploying it everywhere. Governments are starting to rely on it, as you know. But this gap between demo and production keeps showing up. So let me ask both of you. I'm going to start with Tim. Is that the right way to think about it? That the industry has solved intelligence, but not this reliable execution? And what are you seeing in practice today?
It solves some things, yeah. I mean, LLMs are undoubtedly incredibly capable, and they're affecting each and every one of our lives in ways known and unknown already. And I think there's a sort of like mass scramble across the world, down to the solo founder and entrepreneur, all the way up to large multi-billion-dollar enterprises, to get on this train and start implementing AI every and which way they can. And that's where we're running into the bottleneck, and everyone's scrambling, right? You can pay, I mean, all the top model providers, they make their most capable. I mean, first of all, the economics of it for the end user are changing quickly, because these companies are not able to sustain this Ponzi scheme-esque sort of economics that they've been propping up for the past 3-4 years, where it's just all subsidized by VC funding. They're running into the cost themselves, right? Like Claude Code, I mean, they're giving away $200 a month subscriptions, but incurring $10, $20, $30,000 in costs themselves for that $200. So I think the pricing of this entire structure is going to change, because the incentives are also for these companies to charge you for more tokens, right? Like they get paid for every token, every word that you ask the LLMs to the models to produce for you, and which leaves a wide space for research labs and companies like us to find opportunities and capture opportunities that solve problems that arise from this misaligned architecture and incentive structure. And I mean, we're seeing this need, as I mentioned, across the spectrum. I mean, we have more than 250 signups to the private beta, ranging from solo founders to multi-billion-dollar companies. Like, I went through the entire list a couple of days ago. I couldn't believe who was on there, and like, shit, I wish I could say it, but it's like I was like, what? Like, for real? Which is one, obviously just super exciting, but two, it just really validates the entire problem we're tackling here and the gravity of the problem we're tackling here. And I think we're really far ahead of the curve here, and we have an opportunity to create a massive moat, particularly in the data capture that we're going to be creating here with these funnels, where each and every sort of iteration and use of our system is going to create more data, which we can use to train subsequent iterations. And that step of generating these structured reasoning graphs, which will be the standard for how people use this in production moving forward, gathering that data, capturing that data, being able to fine tune and iterate on that across different organizations, different companies, different use cases in different domains, scaling that from 10 to 100 to 1,000 to 10,000 to 100,000 users is going to create a massive moat. And that's what we're working on. That's what's happening right now. We're going to be opening it up, the private beta, to the very first handful of people. I believe in the next week or so, just the very first handful. It's going to be a staged rollout, and we're going to take our time to make sure we give the right people the right attention, starting with the biggest companies. So we're excited to start collaborating with some publicly listed companies here on this in this early phase already of the product we're building. And yeah, I guess I went on a bit of a tangent there, but
No,
I guess
that's great. That's great because you've established that the models are powerful, the demand is massive. We all know that's obvious, but the way that they're currently being used and structured breaks down under real conditions, except when you see these graphs that have been implemented by this serve reasoning framework, right? And so that really is a really nice layup for Armand here, because you've been seeing great results from folks, and I want to go directly there. Like, what's the actual solution here? What are you doing differently at the reasoning layer that addresses this bottleneck that that Tim is seeing so much interest from his side?
So let me circle back to what you said. Raw intelligence is tackled well by the underlying large language models. We see with every new generation of models, the raw intelligence is just like going up and up, and like they're getting better and better at solving harder tasks. The problem is there's a lot of variance in their performance. Given the same task, the same model solves it in 10 different ways, and only one or two of them are actually really good. And you keep burning tokens. I'm sure all the white coders here, all the builders will immediately know what I'm saying. Like, you have to say, yeah, no, it didn't work. No, you broke this. No, you need to fix this now. Do this thing, which is not agentic. Ryan, we had several shows with you before on YouTube, and this was a topic that we discussed. We made the definition of what is an agent and what is autonomous. And like, if you have to step in, that's not autonomous. If you have to direct it, it's not autonomous. Autonomy requires consistency, right? And consistency requires a fundamentally different thinking in this world of statistics, because let me give you one technical bit. Previously, around like up until I guess the end of 2024, maybe early 2025, we were able to strictly define the solution space for these large language models, and we were able to get them produce exactly the same output for a given input. We were able to say, don't hallucinate. Like, don't even if you hallucinate, don't give me any other response. Give me the same response every single time when I write you this sentence. And then the companies just took away that that solution or flexibility from our hands. Nowadays, these like the responses are all over the place. You never get the same quality output, never. And if it's working for you, it's kind of a coincidence. So this obviously does not work for an enterprise, right? They want predictability. Even if raw intelligence isn't that high, or even if it's doing mistakes, they want the agent to do the same mistake over and over again, given the same input. so that you can design around it. And that is the fundamental thinking. If you can constrain the agent to output predictable results in a more accurate, in a more reliable way, then it's more manageable and workable in a multi-agent setup. So what we're doing with this bounded reasoning graphs is we're limiting the possible set of actions an agent can take. And then based on that, you get a much more predictable output. So, without bounded reasoning with regular English sentences, the quality of an output, we're measuring these like every single day. We're doing hundreds of benchmarks. The variance you'd see would vary from like 10% accuracy to 90% accuracy. If you apply bounded reasoning, you get like 70% accuracy to 90%, 95% accuracy, which is way more useful for a company, because then that's real. That's something you can build on top. Especially, as Tim said, if you add multiple agents for a single workload, for a single task, if 10 agents are collaborating, if one makes a simple mistake, it's very difficult to correct afterwards, because not every single agent knows what agents come before it. They just act on input. What if the input is wrong? Well, you are done for. And in a multi-agent setup, the task takes like 5 minutes, 10 minutes. If there's a mistake in there, you just lost 10 minutes and a bunch of dollars.
Yep.
Which is really sad. And like, you immediately lose customers. We saw that people would prefer manually, like spending 30 minutes in manual work instead of guessworking and like missing maybe 10 or 20 minutes of their work just because AI made a stupid mistake. And this observability, this accountability, we call this explainable AI. The AI should also be able to tell you what failed where, so that you can recover and maybe understand and fix. Right now, again, I'm sure, I don't know why I'm blurred. I'm pretty sure most builders will understand and recognize when I say, when you have like 10 paragraphs of a system prompt, and if it's not working the way you expect, what are you going to do? You change a word, you get like completely different results. First, how do you know they're better? Second, how do you know which one is actually the problem? Which paragraph is the actual problem? It might not be there where you think it is, because large language models don't think like humans. They don't think at all. It's just a statistical machine. And this is a great comment. Precision and accuracy are different. Maybe I should use this term more, precision. We need way more precise answers, even if they're wrong. The targets should be locked, basically. And this is what we're enabling through our approach in the API. And as a philosophy on our paper, right? Like, when we first set out, we made this research public because we believe this is going to help everyone in the world if like everyone starts building a version of what we're building. And then we have so many more different ideas and features to build on top of what we made public. Like, we're going to start with this API. We're going to train our own models, and it's a huge chain of deliverables. We have a really jam-packed roadmap that we want to ship to market, and I believe we have a solution to reasoning. And if you think about it, reasoning does not necessarily require super high intelligence. Like, think of it in real life. It's a process. It's a process. And you don't have to be like super genius. The world is not built upon the work of super geniuses. The world is built upon like predictable outcomes from everyone with like mid-level intelligence. So I guess we're gonna see a resurgence. That's why like our most popular solution is Serve Nano, which is killing practically every single model out there. It's not the smartest model. It's a nano tier solution, right? but it doesn't need to be. It just needs some structure. There's so much more value that you can get by adding a little bit more structure to these large language models.
And Serve Nano also sounds incredibly cool. So, yeah, great comment about precision versus accuracy. For those whose English is not up to Armand's snuff because he's bilingual and genius, precision is you're hitting the middle of the bullseye every time. Accuracy is you're hitting the target roughly every time, right? Precision is exacting, it's reliable. And I think that's why we're seeing results that you're seeing, like 74x performance improvement that was mentioned by by you in Entrepreneur magazine, and also this research paper that's currently in peer review at a top AI journal, already been published by Cornell. So we're not just seeing this in benchmarks; we're seeing it in real deployments. Can you guys share with us, talk to us about the work with Neil and the UAE government? And Armand, I heard you mention the roadmap, so I'm gonna call you guys out on that. I want to hear about that next.
Yeah, I mean, if I can, I think Armand brought up a point that we actually haven't spoken about a ton, and that's a nice segue into Neol, which is one of the enterprise cases that we are green lighted to talk about, which is the debugging component of this all, and that's not something we've covered in huge depth, but the reasoning logs, the traces, the receipts, which eventually will go on chain on our layer 3, because we think that's just the optimal way to create an open, transparent log of and sort of like auditability trace for decision making in agents, right? And Neol was running into this exact problem. And for those who aren't aware, Neol is describes like a network intelligence company that essentially has a sort of like an AI-based product that enterprises and governments use to basically find and source and query human capital and a database of different sort of professionals and resources across different domains in different countries. And it's a super important resource for very targeted use cases that they have. And it's all run by agents. And Neol was having issues. I mean, each agent had a rather simple sort of like task of, fetch the job description or fetch the resume of this or people in this category. But then they changed it again, back to this point earlier. They changed it that we saw in our own production, but exists similarly or equally across many other companies. They had like an 8-step agentic multi-step process, and the end result was something like 50% failure rate. And one of the problems was they were all running on these large English-based system prompts. And whenever something went wrong, or for one, not only is you have this error sort of like compounding error rate problem, but also in kind of like persistent tasks that keep running, the LLM can reinforce its own mistake. So somewhere in the process, it like creates an output, and then it tries to, in the memory system it learns its own mistake and uses that mistake to build on future iterations and future token predictions for the next answer and the next time that process runs again. And you just get on two fronts, you get these ridiculously compounding errors and hallucinations where it just starts talking about complete nonsense and making things up, right? And then the problem is, which they were telling us in detail when we were designing this framework together, was they would go and try and audit this, right, and figure out where the problem was. And they're going back to these just super long, vague, linear English-based system prompts, and they had no idea where to look, where even to start, because there's no clear sort of like reasoning, there's no clear decision tree for where the agent made different decision points and how it ended up at a certain venue in that kind of logic, right? It's all just based on this like super vague, like linear English prompting. And this, I mean, implementing serve reasoning and the underlying framework has been an absolute game changer for them. I'd actually like to read you a quote from the founder that he wrote us. And he said one very critical data point was tool call reliability. So we had reliability issues where certain tools were not being called reliably, like web search, for example. And they've been using serve reasoning to instruct their tool call usage, and they managed to make their pools up to basically 100% expected accurate sort of expected tool call usage across 1,000 sort of iterations or 1,000 executions, up from around 50 to 60% prior to implementing it. Like really, this is a quote: 100% expected tool call usage across 1,000 executions compared to 50 to 60% prior to implementing this. And then back
Holy
to
cow.
the kind of debugging piece. Oh shit! Now I have to find it.
I'm
Well,
flabbergasted. You
anyway,
don't see 100%.
riff on what I just said, but
Yeah, I'm just saying. I'm just like
So
I've never heard 100% in a case study or a
another
testimonial before.
another
and that
problem.
matters, right? In these like Neil has contracts with the UA government and with a couple other governments and large enterprise projects. There's no room for 50 to 60% failure rate. Like if that's the case, they don't have a business, and neither does the end user, neither does the end client have
Right.
a feasible or viable way to get the results they're looking for. So it's a problem on both ends.
Ramon, you were going to say something because I mean, people's lives are at stake when you're doing searches for the governments with the UAE government.
So
So this is incredible.
like another thing, so this is, I was there when this happened, and like it's incredible that now this is working reliably, and Neol has in-house evaluations framework that they heavily invested in for months, in bringing up like or measuring this precision, this accuracy and reliability, because without it you cannot sell your product. You need to constantly make changes for each government unit, government body. You have like you need to make tweaks and changes to your product, right? And you need to ensure that all of the agent orchestration still works 100% and still works as expected. And how are you going to do that without a custom evaluations framework? So Neol heavily invested in this. And one thing that was really good to see previously, they were like, the engineers build a solution, it works on their machine, it works while developing. Sometimes it doesn't. They fix the prompt and they get to a reliably working state. Then they ship it, and in the first demo, the business development person says it didn't work. It didn't really give me the results. And you look at the chat history, the agents, all the tool calls, it didn't. It missed this specific keyword that it should have put in, or it missed this tool call. But why? And how do you get it to a reliable state? And that's why I said in the earlier stream as well, it was a practically an immediate decision. It was a 1-day decision. Yeah, this solves our reliability problem with this
Wow.
framework, with the approach. Yeah, we at least get consistent results. If it works on a developer's machine while they're building a solution, it's going to work for the BD ops team whenever they're in a sales call, right? There are no surprises, which is really good because everyone can sleep at night, in a reliably happy way, knowing that the product will still work tomorrow, and it's not going to be surprises. And if you think about it, I've been in some of those calls. It's a very high stakes environment. There's no room for mistake. Like the people that you're talking to, they don't have much time, and you don't get many chances over and over again. Like it needs to work. When you demo your product, and true, I don't sleep. True.
Neither does Tim.
But the stakes are so high, you don't get to make a mistake. You need to give them the exact result, and of course you cannot fake it. No one buys slideshows, no one buys presentations anymore. If you have a product that can deliver, that's great. And of course, in all of those calls, the customer gets to define what you do with that AI. So you're not even running in a scenario, and your product needs to work the way you expect, the way you designed it. So that level of reliability is what real agentic world has to deliver. And the economy, the industry is still not there yet. And like this is going to come up maybe like by the end of this year, maybe next year, people will understand, oh wait, okay, now in order for us to use this in a business context, we need way more reliable execution. This is just not gonna work. And this is why everyone is reporting on this. Like 90% of enterprise AI applications fail because of this reason. It's just like simply not usable. It works great in a couple of demos. Everything you see on X is the one golden output of hundreds of runs, hundreds of executions.
That's
Yeah.
true.
And our job is to make it reliable. Our job is to make sure you get the same reliable output every single time.
And I think
And
everybody here should remember that, if they don't remember anything else, that this is not just making AI smarter. It's making it freaking usable consistently. Just making it
yeah,
usable.
Which is the
So
problem, right? Like, I mean,
yeah,
we're trying to solve this huge and unlock this huge market of autonomous businesses that are built with AI and operated with AI and launched on chain. And how is that ever going to happen if it doesn't work half the time, you know? And this is
right.
happening across so many different domains, right? Like Neol is a human capital sort of like AI business. One of the beta signers was a genome sequencing company, who have just as much of a need for this to work. I mean, we've had a bunch of traction, and we already have multiple companies in DeFi and in prediction markets who are using this to power their products. Because think about this concept, this notion of AI agents managing your funds for you and generating yield and trading for you. People have been talking about that since the beginning of 2024. Where is it?
Hmm.
Where is it? Well,
Hmm.
it basically doesn't exist yet. Everyone, like, been tons of builders trying to do it, but then they realize they spend a year building their product, and then they were like, oh shit, it doesn't, it fucks up half the time, or it goes and sends my money to someone else, or someone can prompt inject it on Twitter, right? Like, what was it? Yeah, a few weeks ago, there was some AI agent that I think it was launched by a OpenAI dev or something, and it had a wallet, and someone was able, through the comment section, was able to prompt inject it to send all of the funds in its wallet to himself. And this is a huge bottleneck that we are unlocking. And what excites me so much about this is that it's something we've validated from day one. This is not theoretical. This is not like some like hope and dream. Like, this has been since day one, since designing it, co-designing it with Neol, putting it in practice in the early stages of the development of the framework itself, and now opening up the API to early private users. It's already working. This is already real results that companies are already using and getting measurable improvements in, and allowing them, unlocking their ability to win customers and generate revenue and grow. And this is really the foundation of this, stack we're creating here, where autonomous businesses are really unlocked. Businesses that are built with reliable AI systems from the core. And it's all like super exciting to see it come together, and seeing
Yeah.
the energy, the excitement, how much engagement we're getting on social media, the list of signups from, these were large data center companies to, as I said, genome sequencing, to drone companies. Like, I was like, what the hell? Like, and can you imagine just the data set we're going to be able to accrue here, and use to improve this and just jump ahead of everyone else? I think it's an exciting prospect for sure.
So whether you're a solo founder or you're a large organization, you need usable AI. Because if you're a solo founder, your intent, I assume, would be to grow, hopefully to become a unicorn, where then you'd become a large organization that has a lot of constituents and clients and partners that rely on a consistent, reliable product. So either way, I mean, you need this really great, reliable, useful AI. Everybody does in the world. So this makes perfect sense why the build, launch, run lifecycle works, and why you need reliability at every step of that way. But we're all curious. Like, you've cracked the egg, as somebody put. Like, this is sort of a 0 to 1 moment that you have now. What do things look like now that you have cracked this egg for the next 12 months? Like, what's the next for reasoning? Whether it's your roadmap, your the Launchpad, the AI co-founder tools. Spill the beans.
Yeah. So, I mean, we've essentially delivered working products on, so the ability for people to build production grade agents, the ability to orchestrate them into multi-agent systems. People are already using this in production today. That's live. And now we're mainly focused, so our big sort of technological focus is on the reasoning part, which we see as the biggest industry bottleneck at the moment, for enabling this like massive economy unlock, which is not going to happen in a day, right? It's going to take some time to unlock this, probably what is a multi-trillion-dollar industry here of AI powered businesses that can be built by a single person. Think about how many solo founders, solo entrepreneurs are going to be spawning here. Millions, tens of millions. And then we have the tokenization part, right? Like, it's VC funding is not going to be able to cater to all these millions of entrepreneurs and sort of like micro companies, micro products, that are being built with AI and launched. How are they going to fund themselves? They don't necessarily need $3 million in funding. They don't need a 10-person team. They need $50,000. They need $100,000. They need $10,000. They need access to that capital. They need access to an audience. The tokenization is just the obvious answer here, which is how we've come into existence ourselves. So extending that as a product via a launchpad is the natural extension of what we're building here, right? Unlocking this agentic autonomous economy is giving agents and agent-powered products a way to fund themselves. So we have tools to build the products themselves. We're unlocking major bottlenecks in the industry, production-grade agents, multi-agent systems, and now reasoning, the ability for agents to actually work. Then tokenization, for giving access to capital, so capitalization of these companies and agents. And then lastly, the AI co-founder rollout, which is essentially like a tool to automate with AI agents, automate all the kind of heavy lifting operations that a startup and an agent needs to execute in order to grow and market itself and market themselves and grow the community, etc. And all of this is eventually leading towards this kind of, or leading towards this layer 3 vision that we have, is putting it all on chain, where Serve is the gas for this entire thing. Serve is needed to transact across between different agents and businesses. Serve is needed to launch on chain. The reasoning logs of each agent's transactions history is all happening on chain in a isolated environment where we can customize the variables of this kind of, I mean, it's an economy, right? Like, I'm trying to picture it in like 3D terms of a city in Rome, but we're creating this digital economy with different stakeholders, and where on-chain is a core part of that. And that's where we're all heading. And I would love Armand to maybe wrap up just with a specific roadmap on the reasoning aspect of our AI stack, which is, getting a shit ton of traction from solo founders all the way to large enterprises, and is the core pillar of the stack we're building on the AI side.
It's very difficult to not, reveal everything and break surprise and break the egg. But
you can reveal some stuff, like chat about a little bit about the shadow agents we're going to be implementing into here, this sharding architecture we talked about.
That's So yes, I think one big theme is, okay, there are two themes. One is custom models that run inference at a much smaller scale, at a much more affordable economy for reasoning, because reasoning is a separate task than text generation, right? You can train specific models just for reasoning. And this is why we're doing extra research in alternative languages to train these models in. Because what if you train a model from scratch on an alternative language? Maybe that language does not exist yet. It doesn't have to be a human language, right? What if you invent a new language? These are like some of the research aspects that we're tackling. And can you get better reasoning results That's one thing. Um, so custom models. The second one is architectural shifts and changes in the API. Because if you have the power of generating text as a result of a request, then just like I said earlier, why stop at generating text? You can do so much more. You can actually take that, turn that into a process, run it through multiple steps of realistic code, execute whatever results that needs to be executed, and then return the response. So a single large language model call that we have right now is text in, text out. Sometimes it calls some tools, but in general, it like the goal is to produce a response. And never right now does anything else. What if it did an entire process, an end-to-end process that could be code execution, that could be multi-step reasoning, validation, all of the architectures or all of the possibilities that you thought about before, like chain of thought, judge LLMs. There are many different architectures, councils. Maybe you can even pick and choose. Maybe you can even design your own architecture of how you want to deliver that work. The API that we're developing today is the foundation of this. And the technology that's going to enable all of this execution is what we right now internally named as sharding. We're going to take your whatever process you designed in natural language and in English as your system prompt, apply some magic to it, break it up into executable, verifiable shards, and then execute them and give you a much more reliable, proper result than just random English and you don't know why you received that text back.
And how is this different from the like version 1 of the structured reasoning graph generation?
How can I put it in a way to not reveal everything? So it's different in a sense that it's an execution flow that has multiple steps with their own inputs and outputs that you don't have to design yourself. Right now, you as a developer have to design your multi-agent setup. Think of anytime workflows, right? Like with multiple nodes, even on our own platform as well. You have these things, you describe their inputs and outputs to get some reliable outputs or a reliable execution. What if that happened every single time you wanted to run some generic system prompt, which is 99% of all of the system prompts in the world? We have a task internally to gather every single system prompt we can find on the internet, and that's basically food for our custom model, right? And what we see is kind of scary. The level of complexity and understanding of how large language models work is quite not there yet. So the world clearly needs this solution, a better solution of executable traces, executable flows. And what we're going to start off with is practically a productized version of our research. And we're going to keep building on top. And the very first item, this is not confirmed yet, but we're still working on it, is to release the public API with shadow agent support. What if you could enable shadow agents in your API calls? Like even that it's over the top. Like no one has that in the world. What if we had shadow agents as part of each API call? So each text you wanted generated goes through rigorous testing and verification and maybe retries before you receive it. So as we reduce the possibility of you getting annoying results. That's coders will understand. We have a lot of sentiment about Opus 4.6 right now, how its performance degraded over time, and now how 4.7 just came out, which looks exactly like 4.6 2 months ago, like when it first launched. So we are getting annoying results from AI nowadays, and our solutions is basically to trim it down so you get more reliable results. And that's kind of the roadmap. We're going to build more and more solutions on this, to give you better control over the execution of your reasoning, how you want this to reason. If you think about it right now, all the models give you a parameter called reasoning effort: low, medium, and high, or extra high, or max, which just increases the number of tokens that they generate, which gives them more compute. Like, there's inherently no difference in the ability to think. But what if you could have verifiable execution steps, each with their own output, as Tim said, maybe like even verified on chain for your actions? That would be a real unlock, and that's what we're working on. So it's way more than a model. Models are like sand if you want to build a building. They're not even cement right now. You need so much more structure around it, so much more process around it, to build that into concrete and then build a building with that. And we are practically designing that process. So you can get a bucket of sand and give it to us, and we give you a house.
Yeah, I think I just, as you were saying that, I thought of like perhaps a way to sort of frame the roadmap in super layman terms is, if you think of existing model providers as car chassis manufacturers, and right now we're building a new engine replacement, a custom engine to place inside existing chassis to improve the performance of existing cars. The next phase is going to be developing not only a new engine, but a new chassis as well, a custom model, and owning the entire vertical there. So we don't have to rely on the shortcomings of other chassis manufacturers, and we can make everything ourselves.
Vroom,
We like
vroom,
the
vroom.
whole thing.
Vertical integration across the board. I think
Yeah.
you both have spoiled us today with insights, hard numbers. We're talking 74 times and 100%. Please,
There's one more thing I want to say.
please.
This is something I've been discussing with our marketing team since day one. I want to call this a reasoning engine, like what we're doing. It's not a model. It's not an API.
Yeah.
It's a reasoning engine. It's so much more. It's a way of thinking and solving reasoning like no one did before. So much more. Several components coming together, like shadow agents, like the mermaid diagrams, like executable shards. So much more. Many components coming together to give you predictable, reliable reasoning. It's an entire application engine wrapped up in a very simple to use API that you know how to use today. So it's an entirely new product category. It doesn't exist anywhere else. No one else is tackling this the way we are. Please do some research. I would love to learn if there's any competition, and if I can learn something from them, I would love that. It just doesn't exist. No one is tackling reasoning the way we are. So yeah, and you just cannot copy that. It's the moat. How you really, like, what is the alloy? Everyone builds engines, right? Like, you cannot build a jet engine that easily. It's a very specific alloy that you have to have to withstand that. You cannot send drones to Mars or the moon. It's not going to happen. So we have that combination, and we're bringing it to everyone. It's like making space travel available to everyone. So like, I'm very, very psyched up about this. So I'm always trying to say, like, let's not dumb it down. Let's not call the model. It's an entire engine. Model is like a very small, tiny part of this. Yes, it's doing the text generation. Yes, definitely. But there's so much more to reasoning, and yeah, that's what we're on to.
Amazing. So if I could, as we wrap this up, leave it with one last quote from the founder of Neol. We asked him a few questions, and one of them was, how would you describe Braid or Serve Reasoning to a peer at another company who hasn't used it? And his last sentence was, for companies working in high-stakes domains, the auditability matters as much as the accuracy. When a client asks why a particular result appeared, you can point to the reasoning structure rather than shrugging at a black box prompt. That's a qualitatively different relationship with the technology, and is why we're using it at Neol.
Wow. I listen, I've been moderating live streams and public speaking for years. I've never been out concluded like that. That is the best quote. You did. No, but that quote, I'm telling you, every company in AI wants that quote attached to their product, and none of them has it. None of them but you. So congratulations on the success so far. And again, shout out to the community. This is absolutely unbelievable. And the layer has been solved. We're now moving to the engine layer. We're unlocking new categories of businesses, from solo founders building real products to enterprise and governments that are relying on these systems that need an improvement in accuracy, precision, and reliability, and to the broader idea of an agent-driven economy and like all these things that we haven't experienced yet and we haven't dreamt of yet. This stuff actually works. So thank you so much, both of you, for breaking this down. This is an extremely clippable chat, so I want to see those clips on X. Appreciate both of you so much for speaking to somebody 10 times slower than you, because this engine is going fast. Everyone for tuning in, thank you. This is one to keep a very close eye on, and we will see you next time.